Hi, 7th graders. Today we're going to talk a little bit about theoretical probability. And so, reminder that probability is the chance or likelihood of an event happening, and we can express probability as a fraction, a decimal, or a percent between 0 and 1. And so if you have a probability of 0, the likelihood of that event would be impossible. If you have a probability of 1 whole or 100%, the likelihood of that event is certain. And then you have anywhere in between there. The closer to 0 you are, the more unlikely the event is to occur. The closer to 1 whole or 100% that you are, the more likely it is to occur. So there are two types of probability. We have theoretical probability and experimental probability. Theoretical is going to be, in theory, what should happen, or what you would expect to happen. So it may or may not happen this way, but this is just what you would normally expect to happen. So we're just going to look at a couple of examples. These are the practice pages in your book, page 175 and 176. So it says Rebecca ordered a balloon bouquet to use as a decoration for her brother's birthday party. The number of each color balloon in the bouquet is shown. So over here there are 6 blue balloons, 5 red balloons, and 4 yellow balloons. So the first thing that we're actually going to do with this information is we want to figure out our total number of balloons, okay? And so when I add these up, I see 6 and 4 are going to make 10, plus that 5 more is going to be 15 total. So what's the probability of choosing a red balloon at random from the bouquet? Well, I have 15 possible outcomes. And then I'm going to look at how many of those 15 possible outcomes would be, how many favorable outcomes would be red. And so just what that means is basically how many of the 15 are red. And so I can see that 5 out of the 15 are going to be red. Okay, so I have a 5 out of 15 chance of randomly choosing a red balloon, all right? Typically, we want to express our probability in its simplest form. So when I look at 5 and 15, I know that 5 is a common factor of both of them. So I'm going to go ahead and divide them both by 5 and end up simplifying that to 1 out of 3, okay? So I have a 1/3 chance, or 1 in 3 chance to randomly pull a red balloon. So now the next one, what's the probability of choosing a blue balloon at random from the bouquet? So we're going to go back to this 15 total. And then now I'm going to look at how many of those are blue. So 6 out of the 15 are blue, which means that I have a 6 out of 15 chance of drawing a blue balloon randomly. Again, we're going to simplify this. So when I look at 6 and 15, I know that 3 is a common factor of both of them. So I'm going to divide them both by 3 and end up getting 2/5 as my probability. And what's the probability of choosing a red or balloon at random from the bouquet? So when we see this word or, so red or, I'm actually going to be adding up those favorable outcomes. So I have 6 opportunities to get a blue balloon and 5 opportunities to get a red balloon. So this would be 11 out of 15. For examples 4 through 6, use the information to answer the questions. Riley makes a list of the eye colors of her classmates. She finds that 17 classmates have brown eyes, 7 have blue eyes, 1 has gray eyes, and 2 have green eyes. So again, the first thing that I want to do here is I want to figure out what my total is. And so to do that, I'm going to add up the different outcomes that I know. So I have 17 have brown eyes, plus 7 have blue eyes. So if I add those up, I'm at 24. Plus 1 more is 25, plus the 2 that have green eyes would be 27. So I have 27 students in this class. So what's the probability that a randomly selected student in the class has blue eyes? So I know my chances are going to be out of 27, and so out of those 27 random students, 7 of them have blue eyes. So I have a 7 out of 27 chance of randomly selecting a student that would have blue eyes. For 5 and 6, again, we know that our total possible outcomes is going to be 27. So what's the probability that a randomly selected student in the class has brown eyes? So if I look at how many of my students have brown eyes, 17 of them have brown eyes, so I have a 17 out of 27 chance. And then blue or gray, so again, I'm gonna be combining those two, so 7 have blue, 1 has gray, so that's 8 out of 27 to select a student that would have blue or gray eyes. And we're just gonna do a couple of these questions too, so here, these are theoretical probabilities, so again, what should happen? So number 8, every year the school library gives a book to every student in the school. The chances of a student receiving a certain type of book are shown. So these are our theoretical probabilities, okay? If there are 650 students in the school, how many of them are likely to receive a biography? And so when we do these, we're actually going to be using a proportion to help us set it up. So right now, I know that since I'm looking at the chances of receiving a biography, I know there's a 12% chance that they are going to receive a biography. And so really what I want to figure out is what's 12% out of these 650 students. So if we think back to our percent proportions that we used throughout our last chapter, remember percent means per 100. So essentially a 12% chance, if 12% are getting a biography, that means 12 out of 100 students would be getting a biography. And so I want to know, okay, so how many out of 650 would be getting the biography? And so then what I can do is I can go ahead and solve my proportion. So remember, there's a variety of strategies you could use here. You could look for a mental math relationship. You can use your cross products to solve it. And so our cross products here would be 12 times 650 is equal to 100 times x. And when we multiply 12 times 650, we should get 7,800. And if we divide that by 100, we'll get 78. Okay, so what that means is we would expect 78 of those 650 students to receive a biography. We're going to look at number 10 as well here. 9 and 11 are going to be very similar. Just for sake of time and just giving a couple of examples, I'm going to skip number 9. So a car dealership states that there's a 25% chance that a customer will win a prize pack if they purchase a vehicle. If a total of 168 vehicles are sold, how many customers might win a prize pack? So again, we're going to use our percent proportion to help us here. So I know that there's a 25% chance. Percent means per 100. So that means 25 out of every 100 people should be winning this prize pack. And so we can use that information to figure out an equivalent fraction out of 168. Okay, so then again, we could use a variety of strategies to solve this. Some of you might see that 25 is 1/4 of 100, which means that we're looking for a fourth of 168. Or again, you can use your cross products. Here, x would end up being 42. And so 42 out of the 168 customers would receive a prize pack, okay? Or would be expected to win a prize pack. Again, solving the proportion should not be new information. So it's more just making sure that you have the proportions set up correctly, and once you have it set up, then it's just a matter of solving it. Have a wonderful day.